It's a good time to learn the wiring, electrical wiring in a house from this question. In our house, there is a main power grid behind the walls, and you will find three main power lines, which is the earthing wire connected to the earth. There's a neutral wire, which is the return path for the current, and there's also a live wire at a very high potential. And you will see these three main wires shown as these three horizontal wires. Now, usually the power socket network is separated from the lighting network. So over here you see that there's this power socket network that is connected to the live wire for the current to flow in via the live wire to this ring over here. So this ring over here is the live grid. Now, there's also a return path, the neutral wire. The return path is connected to the inner ring here. And then also there's a earthing connection. As you can see, a 30 amperes fuse protects this power socket network. Now, independently, the lighting circuit is separated from the power socket circuit. So over here, there is this lighting circuit that you're supposed to complete the drawing. So this is how to complete the drawing. The lighting circuit is shown in orange. Live wire current flows in. There's a 5 amperes fuse protecting the whole lighting circuit. And current flows in, and then first parallel path, it goes through light number 1. There's also a second parallel path that goes through light number 2, and you can just repeat this to have multiple parallel branches, each one containing a light bulb. So this is the lighting circuit, and all this, when the current passes through the light bulb, there must be a return path back to the neutral wire, and that is the connection over here. So this is how you draw the lighting circuit in part A. Now, you're also supposed to draw the power socket. How does it connect to the ring circuit? So this is how I've drawn it. The earthing hole in a power socket is connected to the earthing wire, which is the middle ring over here. And the live hole of the power socket is connected to the live terminal, which is the outermost ring, where it's connected to the fuse. Then finally, the neutral hole is connected to the neutral ring over here, where the return path for the current can take place, going back to the power grid. So this is how you can complete the circuit diagram. Now in part B, you are told that the light bulbs, these two light bulbs, if you apply 230 volts to it, they will operate 100 watts each. You are also given that in this power socket, you connect an iron. If you apply 230 volts to the iron will use 1 kilowatt of power. So all three appliances are switched off for 2 hours. Calculate the total amount of energy in kilowatt hour and also the cost of it. So what I did here was I use the power times time equation, keep the time in hours, which is 2 hours over here, and keep the power in kilowatts. That's why I divided the power by 1000 to form kilowatt. Now, numerator here shows you the power of one of the light bulb, 100 watts, second light bulb, 100 watts, and the iron, which is 1000 watts. So together, if I operate them for 2 hours, I will use 2.4 kilowatt hour worth of energy. Then just multiply by the cost to get the 48 cents needed to power these things for 2 hours. Now in part C, what is the number of electric irons that can be connected without blowing the 30 amperes fuse? So we have to figure out each iron, how much current does it draw, and from there we can just do a division to find out what is the total number of irons without bursting 30 amperes. So let's use P equals IV. We know that the power of the iron is 1000 watts. If I apply 230 volts, and indeed in this circuit we apply 230 volts of EMF, so each iron will draw 4.35 amperes worth of current. And you just do a simple division, 30 amperes divided by 4.35, you get 6.89. You must round it down. So if I use 6 irons, I am still safe. The current drawn is lesser than 30 amperes, the fuse will not burn. When I connect my 7th iron, then the current drawn will exceed 30 amperes, the fuse will burn. And you have to replace the fuse. And probably remove the irons first. No one uses 7 irons at one go.